Hello, my name is Kiana White, and today I will be covering Experiment 1 charge tapes for Physics 2212 at Georgia Tech. Um, first, for the table of contents, we're going to do the purpose, the fundamental principles, the results, and the discussion. So, 1, the purpose. So, the purpose of this experiment was to examine electric fields, how the electric fields how the electric fields of the tapes interact, to determine the amount of excess charge, to determine whether the tape is positively or negatively charged. So this was done by placing, or first getting two equally linked pieces of tape, placing one piece of tape flat down on a flat surface, and then putting the other tape right on top of it and ripping it off really fast to create a charge on the tape. This was done twice to create two charged pieces of tape. The tapes were then interacted with other objects, such as my hand, a neutral object such as a piece of paper, and then a charged object such as a pen or something else that can interact with it. And then we observe the forces that interact with the tape. And then I'll go over the results of that in the results section. So the fundamental principles of this lab are going to be Coulomb's law, the gravitational force, and the electric field. Coulomb's law is 1/4 pi epsilon naught times Q1 Q2 over R2 times R hat. The gravitational force is mg, with g being 9.8. And then the electric field, which is the same thing except for the two charged particles, we're just looking at Q, which is just a charge of one single atom. So now we'll go over the results. So first, we can assume that the two pieces of tape were equally charged. The tapes also act as a point charge. Findings. Oh, we can also assume that we can ignore air resistance. I forgot to write that, but just saying. The findings were that the tape was positively charged, and this was observed by interacting different objects with the tape. So, such as my hand, whenever my hand would go near, it would attract. The tape would attract to my hand. Whenever the neutral object was near, the tape would also attract to it. And then whenever the negatively charged pen was interacted, it was attracted. However, the two tapes repel each other to let you know that they are the same charge and that they are positively charged. So yeah, the tapes repel each other, indicating that they were of the same charge. Also, another thing is, I forgot to put this in here, but I'll go over it at the very end. So here are some of the results of the experiment. So what is the length of the tape? It was 8 inches long, and I used my iPad to kind of measure it. So everything's kind of approximate, so I didn't have a ruler. So it was 0.2 meters. Then the mass was 2 times 10 to the 4th, or negative 4th kilograms, which is 0.20 grams. The distance between the tapes when they began to float over one another was 0.08 meters. So this is when, after the charged particles or charged tapes were created, I would then laid one piece of tape on the flat surface, and then put the other piece of tape holding it at a distance to see when the second piece of tape would repel the other tape. And I noticed this was about approximately 3 inches. Again, I didn't have a ruler, so this was all eyeballed, so it could have been less, it could have been more. These are the numbers that I used. And the magnitude for the gravitational force was 0.00196 newtons, which was used to calculate by taking the Coulomb's law formula and then backtracking. And then we also saw using gravitational force to get the electric force because of net force. We know that it must be 0, so Fe is equal to negative mg, so we were able to figure out that. And then that gave us an electric charge of 3.73 times 10 to the negative 8. Other results that I forgot to go over, the electron deficiency per atom was 5.825 times 10 to the negative 7th. I forgot to put that in there, but that's what it was. And so now on to the discussion. The what are the signs? What if the signs were reversed? So if like neutron or if protons were negative and electrons were positive, there would be no difference. That's just a change in like convention. So everything would still be the same. We would just address them very differently, but it has no effect on the results here. It was just that everything will still be the same. We'll just call them, instead of calling them electrons, we'll call them protons. So everything will still be the same. And then comparing the point charge and the line charge model was closer to the actual value than the point charge, and this is because the line charge represented the experiment a lot better than the point charge did. And then here are my computational models and some of the results, and I put the lines of code that are most important in here, and then the code also tells what the gravitational force is, what the magnitude is, and all of the results are listed there. So thank you so much.